You've been introduced to the idea of scientific notation before, but let's just review it because it's been a few days, right? Okay. Scientific notation. Can someone give me an example? What does scientific notation look like?
10 to the power of something.
Yeah, you've got a 10 to the power of some number, like say, I don't know, 5. And then at the front, what do you have? Well, if we wrote it out as a full number, there'd be, you know, I guess 5 zeros, right? But at the front, you've got some, you know, significant figures of some kind, okay? So you've got a number like this. That's what scientific notation looks like. Can you remember why? What's scientific notation for? What's the point? Why do scientists use this kind of thing?
To make it like more simple.
Yeah, that's right. It's simpler to write very large numbers, or alternatively, very small numbers like 0. Like Georgina was saying, 0.0000034. It's easier to write big and small numbers in scientific notation. It doesn't require so many zeros. Okay, so I just want you to remember, how do we actually convert a number into scientific notation? So, if I gave you this, I'm just making this up right now.
Oof.
Okay, that's a big number, right? It's a good candidate for something we can turn into scientific notation. Okay, so I'm going to say equals, right? Now I've got a few different pieces here, and I want to work out what do I do for this one that'll make it look like that, right? So what was the very first step? How many significant figures does it have?
4.
It has 4 significant figures. 1, 2, 3, 4. These zeros doesn't matter, okay? So the very first step is write down the first significant figure. So there you go, 5. So you can jot that down. What do you get after the 5? Just decimal point. You're always going to get a decimal point after, bless you, that first significant figure. So 5 points. What happens after the point?
2.
Yeah, just the rest of the significant figures, right? In this case, 2, 3, and 8. And you can see, just like Sapir mentioned before, there's 4 significant figures here and 4 significant figures here. Okay. Now look back again. I need to multiply by 10 to the power of something, don't I? 10 to the power of something. Now, to work out the something, I want to look at where this decimal place has gone and where it came from. Okay. Now, I'm not going to change the number. I'm just going to put a 0.0 there. See that? It hasn't changed the number. It just puts a decimal point in the position that it should be. Now, I want to work out how far did this decimal point move in order to end up over here. So I'm going to count, right? Here's how I'm going to do it. It goes 1 place, and I'm just going to keep on going all the way. 2, 3, 4, 5, 6, 7. You see that? And now it's between the 5 and the 2. Okay? So since it moved 7 times, or 7 places, that way. Okay? I'm going to say 10 to the power of 7, and that's it. You've converted it. Okay? That was a big number. Let's just, for the sake of illustration, I'll give you a small number. Suppose we had this, 0.0046. Okay? I'll ask the same question. How many significant figures?
5.
Ooh, okay, now there are 5 digits, right? But are all of them significant? Now, over here in this example, I had a bunch of zeros, and I said, now these zeros, not significant. It could be like an estimate, like a round number.
Zeros before.
Yeah, okay. We'll get to, zeros are sometimes significant, so that's good. But I'll show you why in a second these ones aren't, and some other ones are. Okay. Now, in this case, there are just 2 significant figures, the 4 and the 6. Okay. So, what did I do up here? I wrote down the first significant figure, right? That's a 4. Okay. Then what?
6.
Decimal point. And then the 6, the other significant figure. And there you go. 2 here, 2 there. Now I'm going to multiply by 10 to the power of something, right? So I'll do exactly the same thing. My decimal point, I want it here, but it started over here. So I'll just have a look at how many times it moves. I count 1, 2, 3 times. And that's where it ends up. Okay? Now here's the thing though. Remember we said this is a big number. Big number here, small number here. So that means this isn't 3, even though it moved 3 places. Right? Do you see why? It moved in the other direction. Okay, so that's why it's going to be not 3 but negative 3. Okay. Ta-da. Now, just on Jack's question before, sometimes zeros are significant. I'll show you when they're significant. If I change this number and put a 0 there, see that one there? That's different. Okay, that 0 is significant. Why? Why is that one significant but these ones weren't? It's because of what's on either side, right? You see you've got a 4 there and a 6, right? So because those are not 0, we know they must be significant. And any numbers between them, regardless of what they are therefore also significant. Yeah.
There was no 6.
So if it was like this?
Yeah.
Okay. Now, if it were written like that, which I'll admit is unusual, I would actually probably conclude that it is significant. Okay? But this is a bit tricky. This is tricky. Like if I gave you the number 40, you would guess that there's just one significant figure, right? But suppose there was, 2 classes of, year 10 maths, and I counted you up, and there was exactly 40 people. Not 39, not 41, exactly 40. In that case, both figures would be significant, right? But you can't tell that just by looking at the number. You can only tell because I explained extra stuff, right? In the same way, it's a bit tricky here. We would avoid writing that and giving that to you as a question, unless we provided extra information, okay? Yeah?
What does truncate mean?
Truncate. Truncate means chop off. So just now, I had a 6 there, and I truncated the 6. So I sliced it off. Okay, so that's all it means.